They're produced by machines. Packages. Packages for toothbrushes, soft drinks, sliced cheese, and countless other everyday products. To make them, millions of tons of plastic are needed each year. The material is nice and light and can be transported using little energy, but first the packaging has to be manufactured out of recycled plastic or petroleum products. Each year, more than 1 million tons of plastic wrap are needed just to make bottles easier to transport. The Project Automation Engineering Company in the town of Kannenburg on the Lower Rhine has developed a new packaging machine. Instead of using shrink wrap, this machine binds the bottles together with an ultra-thin, 40 micrometer thick strip of plastic. The bottles are placed into a shaft. A roller feeds the plastic strip into the shaft. The strip is threaded through under excess pressure. Air pressure shoots the strip into the shaft. Here, vacuum pressure draws the strip onto thin conveyor belts. This so-called air vacuum transport system wraps a single strip of plastic around the bottles. A rod holds the strip in place. The roller pulls it tight with great force, and the strip is sealed. The machine wraps 40 units in 1 minute. The air vacuum transport system makes the high-frequency rate possible. High tension enables a small strip of plastic to hold the bottles together. That reduces material use by 75% and saves a great deal of energy as well. The bottles used to be completely wrapped in plastic. The foil was heated, which caused it to contract and form a transportable package. This process is no longer needed. That saves material and reduces energy use by some 95%. Also cutting back on greenhouse gas emissions. For a normal small-scale bottler producing 50 million units a year, the machine pays for itself within 1 year. That's because you save 300 to 350,000 euros on foil and energy costs. A further process attaches a carrying handle to the plastic wrap. The result is a simple transportable package. The principle behind this material-saving outer packaging can also be applied to other products, such as bags for construction materials. Packaging machines can save material for other uses besides outer packaging. Yogurt cups, cheese containers, blister packs for toothbrushes. In Europe, nearly 3.5 million tons of so-called thermoformed packaging is manufactured each year. In this production process, plastic foil is unwrapped and heated between 2 aluminum plates. After that, it's formed by a tool with the help of pressure differentials. That means the heated foil is blown into a mold. Out comes a container or a cup, and it can be filled with pens, toothbrushes, or yogurt. In Dresden, engineers at a spin-off of the Technical University and Fraunhofer Institute have developed a production process for thermoformed packaging that saves material and energy. A demonstration unit of the Vatron startup explains how the technology works. A sheet of foil is heated between two ceramic plates. Excess pressure then presses the heated foil into the mold. The ceramic plates heat the foil evenly over its entire surface. When the foil is blown into the mold, the middle section is stretched the furthest, like a balloon. That gives the cup thick sides and an especially thin bottom. The original foil has to be thick enough to keep the bottom stable. That means the sides contain more material than necessary. To solve this problem, the Dresden engineers have developed a special process for heating the foil. There's electrical resistance under every 5 by 5 millimeter field of this ceramic surface. That means each field can heat the foil to an exact temperature. After it's heated, the foil is blown into the mold. The newly developed matrix heater has the advantage of heating the foil with the help of a so-called temperature field. The cup now has higher temperatures on the outside and lower temperatures in the middle. Thanks to this differentiated temperature field, the flow behavior of the plastic foil is optimized for the given mold. The bottom and sides have almost the same thickness. That way, a thinner foil can serve as the original material. This technology saves material for making cups, as well as packaging for cheese and toothbrushes. The packaging is normally provided with 3D data that allows engineers to calculate the temperature profile for the matrix heater. And that leads to optimal flow behavior when the foil is blown into the mold. We can calculate the temperature profile for the mold, optimizing material use together with the matrix heater. Compared to previous methods, the innovative process reduces the amount of plastic by up to 20%. And since the matrix heater works with exact precision, the amount of energy used to heat the foil is also reduced by up to 20%. It is possible to upgrade conventional packaging machines with the matrix heater. The size of the heater can be adapted to the surface size. With the help of this new technology, the engineers are producing material-efficient packaging for a pen and paper promotional gift. Measurements show that the sides and bottom of the package are thick enough, even though the original foil was 15% thinner than the previously used material. Upgrading a machine like this with a matrix heater pays for itself within a year. Innovative packaging machines help save material and energy. Considering the large quantities of outer and thermoformed packaging produced each year, the savings potential is enormous, and for more than just plastic. If this innovative technology were consistently applied on a global scale, the energy from several power plants would no longer be needed. The new technology quickly pays off for companies and for the environment.